stop. Let's I share the screen. So it's okay. By then, I think I try to. Bukan not using this one. Alamak silap. Oh, this one. Another one. This one. This one. So let's start recording now. This one, I'll just stop this one. Wait two together. Later my computer will hang. Wait okay, we continue with chapter 9. Chapter 9. So chapter 9 is partial differential equation. Partial saya punya my handwriting will be a bit ugly because the pen that I'm using normally I'm using no battery already, so I have to use another. Kena guna pad yang lain, so saya tak biasa dengan ini. So this is in the short form, normally we call it a PDE. So S because of that's the equation lah. Okay, so last time, last chapter, you learned about ODE, and ODE, that is ordinary differential equations. So what is different between this ODE and PDE? So before this, in this ODE, we have two types, right? Initial value problems and boundary value problems. And normally we have like this. We have a function like this, dy dx, okay? Differentiation of y. Okay, respect to x lah, okay? And we can write in this form as well. Okay, where in here, PDE, okay, in ODE last time, and this is the independent, sorry. Independent variables, okay? So this is x is independent variables and y is the dependence variables. This is the dependence. So that means the value of y will change if the value of x changing. So it's depend on x. So x y will difference based on will be based on the value of x. Okay. And when there is like the example of the equations can be like this. For example, we have here y prime, that means divide dx lah, equal to x squared 1 minus 3y. And that, if let's say this is the initial value problems, that means the value of the initial value is given when x is x0. Okay, and this one for this ODE last time, okay, we have independence variables, and the independence variable is only one. Independence variables. And the dependence variables, it can be many. For here, this example, we have only one. So it can be more than one. dependent variable. Okay, so that means x will not, I mean the x is already fixed, okay? It is independence variable, we only have one. So last time, this one is ODE. Now, if let's say we say that this is the PDE, what's the difference between these two things is, saya nak gerak ke sini. Ay, lama. Sorry. Tak boleh gerak. Macam mana? How do I move this one? Last time I also have this problem. Tak boleh. So I just move. Wait, tak boleh. Sekejap. I want to move this one. Yeah. Sorry. Macam mana saya nak move this one? Wait, go back to this one. Okay. So this is ODE. Now PDE. So alamak. Sorry. So PDE is like we have we write in like this, right, in this form. So, and what is this? This is actually both of these x. Both this x and y is actually, this is the independence variable. Where it will change the value of this one, value of u. This is dependence variable. So for the PDE, that means it will have two, or it can be more than two independent variables. And the dependence variables is here, the example here, u is dependence variable. So here is 1. So it can be 1 or even more than 1. Okay. So boleh. So, and normally the PDE we will write in this form. For the ODE last time we write in dy dx. That means derivative. Okay, derivative, first derivative or second derivative. But for this PDE, normally we use like this. Let's say the example, the equation like 3 del, we use delta, del this the second partial of u respect to x. For example, macam ni lah, it can be like, and it can be also like del u. It can be sama dengan x plus x. Okay, if you look at here, the symbol here we use delta. Okay, not because how to say, because it has difference, it can be have more than two or more independent variables here. So here, look at this equation. So x here, kenapa jadi macam ni? Garis pula. Okay, this x and y is actually the independence variables. Oh, ayo, hai. I'm sorry lah. This time, you see, tulisan duduk sangat. Okay, so that's why, and why we use partial. We didn't use D. We didn't use this symbol. Didn't use this symbol. You didn't this symbol because why, you know? Okay, the derivative, the d that we normally use is that we want to say that the change of something based on that independent variables. But because of this PDE, because of we have different independent variables, so that this u, if let's say this equation based on this one, that means this u, this value of u can be changed due to this one x, and it also can change due to partial derivative. But how to say the changes is not totally based on x. Okay, so it's just partial of changing, something like that. Okay, so that means it can be changing due to x, it can be changing due to y, and it can be changing based on combination x and y. So that's why we use partial or delta, the symbol delta, del here, del this one. Kalau biasanya if let's say we read this one okay, let's say I want to read this one I will read as second partial of u respect to x. Okay, and let's say if this is only first derivative, let's say del u over del y. So this is the partial derivative respect to y. Okay, partial. Ni PDE punya equation, maksudnya PDE partial differential equation, partial derivative ataupun differential. Samalah, derivative to dy dx that you learn in chapter 5 numerical differentiation kan, first derivative, second derivative. Okay, so this is a partial derivative ataupun partial differentiations of u respect to y. Partial of the derivative respect to y. Okay. And last time, remember when we do the ODE, okay, if let's say it's given the equations and we have the value of x, right? x0, x1, and until xn. If let's say initial value problems, y naught is given, and this value, this y naught is given, and then we have to find the value of y1, y2, and so on until y. Tak keluar. Apa masalah? Yn. This one. Yn. Okay, so we have to find the value of y1. So, but it's only in x exit. It can be said that in one exit only, x exits. But because we only have one variables, independent variables, that is x. Okay, so but then for the PDE, normally when we want to find the solutions, why we use PDE? Because sometimes we have the problems that we need to find, let's say some value. Okay, let's say this is a x. So we want to find when we have the value of, let's say we have x0, x1, and so on until xn. And maybe over the times, or kenapa tak keluar? Dia punya sensitivity. This one can be over the x or can be over the y ataupun can be over the times. So over the time. So we want to know the value of x. That means we want to know not only in this x, how to say, exits, we want to know for the y exit as well. Let's say this value at here, this point, this point, this point, this point, or even at this point, this point, this point. Basically, that means we want to know the value for the grid line. It's like a grid line here. So you want to know the value of here, 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 and so on. It can be here. All of these points. Okay, so this is a difference between ODE and PDE. So in this chapter, we want to learn how we are going to find all this value like this. So in two axes, X and Y axis, the Y, it can be Y or even it can be T over the time. So for example, we want to know when, let's say, when there is a fire in the buildings, let's say, and then the fire is going to burn the bin. Okay, so we want to know along the way from the distance. I mean, from the distance of that bin from the fire. Okay, the X here, that's mean the distance. Let's say we are putting the fire here. The fire is over here. So kat sini we want to know from here kat mana dia punya temperature of that particular locations over the time. Okay, can be over the time. So this one is can be over the times. So how after how many minutes? So at that particular point, how much the temperature at that particular point of the bin? Okay, so this is a basic. Normally, this is the starting point of we normally doing the solutions when we want to do the simulations. So after this PDE, normally after that, we can use another methods. Okay, normally in this chapter, what we will learn is finite difference methods. It's similar to the previous one, but the finite difference methods will have different types of technique. Okay, so belum lagi masuk. Wait why just now? Okay, another example, let's say, okay, for the PDE, let's say we have the volume of cylinder. Let's say we have volume of cylinder like this, pi r square h. Okay, let's say this one. And we want to find the rate of change of the value, the volume, based on the radius. Okay, radius. So that's why we use, and because you see, the volume of the cylinder can be changed due to the radius or even the height of the cylinder. This is the radius, right? And this is height of the cylinder. And let's say we have a cylinder like this, right? So what will make this volume of the cylinder change is based on the cylinder, the radius and also the height, right? So maybe because you only want to look at, so this is a two independent variables. Okay, so that's why let's say I want to see del V over del R. So that means I want to know the partial derivative of volume V respect to radius. So what is the changes of the volume if let's say we change the radius? Okay. Okay, now we go to the so far okay, class? Okay, well, okay, So Abu Hafizuddin, okay or not? Your friend with you who already? Siapa dah sekali dengan awak tu? Tadi Iqmal.
Iqmal.
Iqmal okay dah, Iqmal?
Saya okey doktor.
Okay. Jangan saya cakap ke sini lepas tu main game ke sebelah sana Okay, we go to the chapter 9. Tadi macam dah tulis chapter 9. Lepas tu sekarang tulis chapter 9 sekali lagi. Saya rasa saya tulis guna teks. Sorry, I think this is better. Okay, chapter 9. So chapter 9. Tapi kecil ke? Boleh zoom besar ke? Oh, kejap. Tak apalah. So chapter 9 PDE, we have I just remember that my pen is no battery. And then I want to buy, and then the shop over here didn't sell. Battery 4A. Saya pun pertama kali tengok battery 4A. A. Saya cari semua kedai kat sini tak ada. Kecuali Shopee. And then it take like few days to reach. Okay. Here we have basically for this PDE, we have three category of PDE. Okay. Slow sikit. Aduh, bila nak habis kelas macam ni. The first one is parabolic. The second one is hyperbolic. I guess that you learned this PDE already in your last class. Dulu kan, calculus ke mana? Apa engineering maths, I'm not sure lah. Mungkin dah belajar, tapi ingat-ingat lupa-lupa like that. So the example of parabolics is heat equations. For example, this heat equations. And the example of parabolics, hyperbolic is wave equation. And for the elliptic, we have basically two equations. One is Laplace, and another one is Poisson equation. So, kalau lah, if let's say this heat equation, we can solve it using two methods. Okay, one is this explicit finite difference method. And another one is using implicit, okay, Crank Newcoulson. Tak tahu sempat ke tak nak habiskan syllabus. But I have to at least cover all that will come in your final, right? Untuk chapter ini. Okay. Sebab banyaknya yang nak cover. Okay. And this is using finite difference methods. And these two also will using finite difference methods. Okay. So, yang semua ni akan cover in your syllabus actually. So, now today we will start with this one lah. We will start with the parabolic heat equations, explicit finite difference methods. But before that, let I explain to you dia punya basic dulu. Okay. So, let's go to sekejap how we are going to categorize. Oh, before that, PDE. Saya pun terlupa lah. Okay, we can write how to say, when we have, just now I already mentioned, right? PDE, when we have more than one independent variables. Okay, so let's say normally the independent variables in PDE, independent variable adalah normally is like X, Y, ataupun T over the time. Okay, over like temperature, over the times kita want to know. And normally the dependent variables kita akan tulis dalam U ataupun V. Okay, so and for the PDE kita boleh tulis dia punya subscript. We call it the subscript. Okay, macam ni. For example, I can write in this form U prime. U prime, that means U X kecil. U subs, apa? Kalau in Microsoft Word, yang kecil apa? Sub apa? Panggil apa lah? Ni yang kecil tu kat belum. Subscript. Betul. Subscript tu lah ya. Subscript. Okay. So this one is actually, that means this is same to del U del X. derivative of u respect to x. Okay, so tapi del u prime also can be uy. Okay, uy, that means partial derivative of u respect to y. So that's why sebenarnya u prime ni kita jarang guna dalam PDE because we have more than one independence variable. So it can be respect to u, it can be respect to y. Okay, so if let's say if u double prime pun kita jarang guna. So if let's say second derivative, the second order derivative, there is this u double prime. So kalau u double prime, it can be u x x, ataupun you can be u y y, or it can be u x y. So that means kalau kita buat dalam bentuk this is the second partial derivative of u respect to x. Macam ni, alamak terkeluar. Ayo, kejap Tak ada betul. I bring here. So this is actually second derivative of u respect to x. Ini pun square. Kalau yang ni adalah second derivative of u respect to y. Yang ini adalah second derivative of u respect to x and y. Macam ni. Okay, it can be like this semua. So sama ada nak tulis dalam bentuk, you can write in this form or even this subscript punya form, subscript form. So they are the same. Okay, so we go to the how we are, since just now already mentions PDE, we have three categories of PDE, which are yang ni kan, parabolic, hyperbolic, and elliptic. How we are going to categorize whether that PDE is parabolic, hyperbolic, ataupun elliptic. So based on the mana cari dulu the equations, based on the equation here, let's say now we focus on the linear second order PDE with two variables. Mana saya letak? Oh, here. Oh. Sekejap. Wait, it takes time to load when it move from. Okay. Let's say we have this one. This one, let's say we have this one is okay, linear second order PDE with two variables. Kalau awak tengok sini, if you look at here, the variable here is actually x and y. Why they say like here, if you see this one, you look at here, this one is respect to x. And this one is respect to, this one, the second partial of u respect to x and y. And this is respect to y. This is respect to x, and this is respect to y. So that means this is only two independent variable. Kat sini boleh tengok here. This is y, x and y, x and y, x and y. Okay. So this A, B, C, D, E, F, G here, actually this is a constant. Okay, constant or function of x and y. This is a constant. So the value, it can be any value. Okay, can be negative, can be positive. So here, if you look at here, we will define, alamak, ini tak nampak pula, whether the PDE is parabolic, hyperbolic, or elliptic based on this formula. Saya rasa pernah belajar tu, B square minus 4AC. We look at this one. So when b square minus 4ac equal to 0, that means this PDE is hyperbolic, a parabolic. If it is more than 0, that means hyperbolic, and less than 0, that means elliptic. So we will have to base on this basic punya, this equation, yang basic ni. Okay. Alamak. Apalah. This one. Inilah equation ni. Sebab sebelum ni kan touch screen. Ini sekarang bukan touch. Here, this one. Okay. So I give you example. Okay. If you look at now later on we look at these equations. So I give the example. Let's say we have example that we have a, let's say we have a road that we have to heat it. Let me put some fire here. Okay, so and then the roof can be from, so let's say this one is T, the temperature. So let's say this one is start from temperature here until we want to know the temperature over here. Okay, it start from here with the certain time of period. So, and it's given the equation like this. Let's say del T over del T equal to K is some constant here. Del U partial of second partial derivative of T respect to K. Okay, if you look at this one, okay. So yang bawah ni kan, this is independent variables. And this also independent variables. We have two independent variables. One independent variables is regarding time. Okay, another the independence variable can be depending of K. K mungkin kat sini adalah mungkin another value lah. Tak pastilah apa. Another parameter. Okay, so that means T and K, it will affect the temperature of this road. Okay, so if let's say if I want to refer these equations, let's say I refer these equations to this equation, the equation atas ni. Apa tak keluar ni, this equation atas ni lah. Oh. Ini equation atas ni. So you see here, kalau sini this is the first one, this one kalau this one yang K, second derivative of T respect to K. Okay, K tu K square. Kalau tengok sini yang mana slide ini kan ada del X. Ini adalah contoh apabila X, it can be any. Tak semestinya X, tak semestinya Y. So for this one, the independence variable are T and K. Boleh faham? Okay. So here, salah satu tu awak tengok the changes of T. So kat sini, kalau atas, over here, this is U. This we want to know the U. But here, we want to know the T. It can be maybe the temperature. So sekarang kalau you look at here, I will refer this one. Kalau tengok sini del square U over del X square. So dia sama dengan ini sebenarnya. It's similar to this one. Boleh faham tak? So that means this is K is A. Boleh faham tak? Can you understand or not? What I want to explain here. If you look at here, this is the dependence variable, which will depend on X, right? Salah satu. One of the independent. Sebab independence variable dia kat sini. Okay, di mana kalau awak tengok sini dia akan tulis U, X, Y. That means U, it will change based on the value of X, and it will also change based on the value of Y. But in this one, this is second derivative of U respect to X, it will based on the X. Kalau tengok yang ni, saya delete dulu. Kelas boleh faham tak? Kalau saya refer these equations, okay, saya tulis balik these equations, I write like this. Saya tulis sebagai okay, I write in here, this form. So it becomes K del T over del K square, and then I put minus del T over del T kecil sama dengan kosong. Kalau tengok kosong ini, G ni kosong lah sebenarnya. G adalah kosong. Cuma sekarang saya nak this one adalah this one compared to this one. So that means A is actually is K. Boleh faham? Kat sini ada B tak? B that mean del X, del Y. Kat sini that mean here bawah dia kena ada del K, del T. Ada tak? Tak ada kan? Ada tak this one? Kelas.
Tak ada, tak ada.
Boleh faham tak ni apa ni? Daniel, can you understand or not what I want to show you? So sini B tak ada kan? B kosong. Betul tak? Kau tengok C. C, dia adalah second derivative of U respect to Y. So, sama ada yang ni awak nak assume this is a C or this is a A. Tapi tadi saya assume this is a A. So dah C kiranya tak ada lah. Kalau C, kalau they say this one, I assume this is a A. So C that mean it should be something like this. Sorry. T and then ini ada tak? Tak ada kan dalam formula ni, tak ada. So that mean C also is 0. So saya akan guna formula this one. B square minus 4AC. Okay, so B tadi adalah 0. Tak ada kan? 0. Alamak, sorry lah. Mixi. Saya punya tulisan kucak kacir. 0. Alamak. Didn't come out. Wait lah. 0. Alamak. Wait lah. Dia tak keluar. Zero tak keluar lagi. Alamak. Okay. Square minus 4. So A just now this one K. A is K. Ini K. C is 0. Tak boleh. Wait lah. Cannot write this one. K. Allah. Boleh K. This one is 0. So let's see. Negative 4 times with K times with 0. That means 0. So we get 0. So that's why this is a parabolic. Parabolic punya PDE. Boleh faham tak?
Boleh.
Kat mana tak faham? If let's say you are not understand, you let me know which part you are not understand. Okay, so now I go to the wave equations. I go to the wave equation. Sekejap saya padamkan yang ni dulu. Saya padamkan yang ni dulu. If let's say you go to the wave equations, I want to show this one. Okay, ini wave equation. Kalau tengok, okay, saya tengok balik yang another equation here. This one, the equation here, it said this is a heat equations. Kalau tengok del second partial of U respect to X. So yang ni adalah apa? Ini kan? Ni kan? Ni kan? So A adalah 1. Okay, saya tulis balik Sekejap. Sekejap. Now, this one, let's say I write it back. Okay, kalau lah saya tulis kan, saya del U del X square. Okay, saya tak tulis yang that X prime T, that is the independent variable. So here we have two independent variable. One is X, another one is T. Kalau dia ada X, T macam tu. So here negative C square. Here is del U over del T. Okay, kalau saya tengok sini, ini kan, this one, you look at this one over here. Dia adalah same. Del U respect to X square. Okay, so that means kat depan ni this is a A. A adalah, kalau untuk ni A adalah 1. Sebab don't have any value here, right? So that means 1. Okay. And then kalau tengok ini pula, this one, del U over del T. Tengok based on sini. Ini bukan. This one is del X, del Y. This is del Y square. Del X, bukan. So this one can be del Y. Okay. Walaupun sebab this one, because this one, the independence is X and Y, but this one is X and T. Okay, get in or not? So that means this is a E. Boleh faham? So the E sama. Ini adalah, so this value is E actually. Boleh faham? E, that means this is negative 1 over C square, yang E. Tapi kita tak perlu, we no need to get the value of E because we want to, if let's say I want to check what category of this PDE will based on this formula, B square minus 4AC. Okay, B here, we don't have B. That means that's 0. B kat sini tak ada, this equation tak ada B. Di mana is respect to X and respect to Y. Partial differentiation ataupun partial derivative respect of X respect to T. Kat sini tak ada. Maksudnya sini, yang ni tak ada. This one don't have. So that's is 0 minus 4. A just now is 1 times with C. C pun tak ada. Kenapa saya kata, why I said that C is, we don't have C for this equation? Because if C, that means it used to be del Y square. Go to this one, because the independent variables is X and T. So that means it should be something that del U, second partial of U respect to T. Dia kena macam ni. Tapi tak ada. So that means here is 0. So that means ini adalah negative 4 darab 1 darab kosong. That means 0. That's why this is equal to 0 and this is a parabolic. Okay. And let's say I give you, we will go and check this one. For sure lah, ini mesti lah, betul kan. Cuma saya how to say, let you see. Okay, let's, when this one, we go to this one, check this one, Okay, yang ni, A dia apa? This is A, right? Boleh tak?
Yes.
Semua blur semua. Saya panggil nama. Boleh ke? Saya panggil nama. So this one, A is Syafiq. A dia apa? This equation. Alamak. A dia apa? This equation. Ni.
Yeah, that one. The first equation.
A dia apa? A dia apa? A.
Delta UXT over delta X square.
Saya tahu. A tu, yang depan tu. Depan del U, del kuasa 2 U, del bagi dengan del X square tu kan. A, depan tu. Value depan dia apa?
A1.
Okay, thank you. A is 1. So untuk this equation, B dia apa? B dia Alia, Nur Alia. Do you know what is B? Alia. Nur Alia. Habis kali dia. Nur Alia. Nur Alia Abdul Razak. Yes, doctor. So the B is what? We got B or not here? Ada tak B? This one. Ada B ya? Ni. B tengok ni. Ni. This one ada tak ni? Ada B tak? Kat mana tak faham? B, we have B or not here? Yes, Alia. Ni ada tak B kat sini? Yang del X, del T. We don't have here. Boleh faham tak? No, okay. That's mean our B is 0. C? Alia lagi C. Ada tak C? C kita berapa? C. Value of C. Nur Alia. So C is ada. C value of C itu apa? Negative 1 over C square. That is C. Okay. So now I want to use B square minus 4AC. B kosong kan? 4 time with A time with C. So this one, negative 4 time negative positive. Dia mesti positive lah kiranya this value. So if for sure it's become more than 0 because this is square. So if let's say the value is negative, it's square, and then it still can get the value positive. And here, dia punya value kat sini depan ni negative. So negative darab dengan negative jadi positive. So here for sure we can get positive value. That means this will for sure will get more than 0. So that's what this is hyperbolic. Boleh. So Laplace and Poisson's is when we do the B square minus 4AC less than 0. And what is different between the Laplace and Poisson is Laplace kat hujung adalah 0. The right side is 0, and the Poisson equation, the right side, we have some value here. Maksudnya dia ada lagi lah some dia punya apa how to say, mungkin it's like X plus 2Y ke, okay, some equation lagi ke belakang, dia bukan sama dengan kosong. Okay. So kalau tengok sini, okay, kita pergi lagi check ini kan. So macam mana? So yang ni kan, kalau tengok kan, this one, dia punya A. Kalau this one lah plus, dia punya this one, A dia 1 kan. A is 1, and then this one is actually C kan. Jadi B pun tak betul, B is 0, and then C is 1. So B square minus 4AC sama dengan, that mean B adalah kosong, kosong tolak 4 darab minus time with 1, time with C is 1. So negative, we get negative 4, nampak sini. So we get negative 4, that means less than 0. So this is elliptic. Okay, so this is category of PDE. Okay, so when you look at, one more thing that you can, banyak sangat ni, sudah pening tengok sini. Saya put here. Oh, bukan copy another thing. Saya padam lah. Okay. Wait saya padam. Okay. Like I mentioned before, okay, this one, because your syllabus only cover for 2 independent variables only. That's why I give you, that's why using this 3 equation with only 2 variables. Okay, if you look at this one, just now I mentioned with you that actually this PDE, we want to know the value at grid point, right? Grid. So that means if let's say you look at here, for the heat equations, we have X and T. Ataupun kat sini you see X and T kan, the value of U. So that means we want to find something that the paksi dia punya apa, exit X is X and exit Y is actually is T. And then we have to draw a grid line, get some grid line, and what to know the point over here. Okay, all the point here. Okay, so this is respect X dengan T. So dia punya paksi Y adalah T untuk heat equation. Okay, so you have to remember X tu memang X lah. The exit X is still X. Only the exit Y is here. Exit Y is T. So the second one is wave equation, also X and T. So that means yang sini pun T, sama juga. Paksi Y dia. The Y exit is T. So only the elliptic here, it's the independence variable here is X and Y. That means we will have to find the value for the grid where this is X and this is Y. Okay, boleh. Nanti kita lukis grid, later on you have to know how to draw the grid, and then here that means this is a Y and this is X. Okay, so that is the difference between these 3, where the parabolic and hyperbolic, our value that we want to find is X and T. Okay, dia punya paksi Y adalah T. Okay, so before I go to the heat equations, I will have to explain with you sekejap saya tengok dulu. I think this one I have to explain. Okay. Page line. If I'm too fast, let me know. Sekejap. Saya lukis balik. I think I have to tell you what is regarding the grid. If you had the book, you can look at the page 216 regarding the discretization of grid. Okay, because PDE we can solve in many methods. Okay, and for example, finite different methods, finite element methods, or even wavelet and so on. But in your syllabus, you only will going to solve the PDE using the finite difference method. Okay, so let's say because finite different method can be said that the easiest method and also is the classic method to solve the PDE. And let's say we assume that we have a plan. A plan with X and T. Okay, saya guna T lah. Okay, saya guna T. Saya tak guna Y. So this one can be said that is untuk heat equation and wave equation. Okay, so let's say we have this one, and that means we want to solve the PDE for this one. Kena besar macam ni baru jelas. Tadi kenapa tak jelas Okay, so here that means we will have this one is these 2 is independent variables and this is the dependence variables. So maksudnya apa yang kita nak cari, we want to find this U, the value of U. Okay, okay, so just now I got mentioned that we will have to find the value at the grid. Okay, so the grid is like this. As I draw, let's say we have we have a x like here. This is x, okay? And let's say this is t. Okay, this is t. So for sure, this is will start with the x naught. Kita start dengan x naught, x1, x2, and so on. And then I will write here lah as a xi, and the next one is xi plus 1. Okay, so continue lah. Sampai the last one xn lah kiranya. Okay, so for this one is still start from t naught, and then this one is t1, this one is t2, and then sampai lah. Okay, let's say this is ti, and this is ti plus 1, and sampai lah yang kita nak cari tn. Okay, so at this point, kalau lah saya lukis kalau saya buat grid macam ni. Tak berapa lurus. It's not very straight. Okay, I'm sorry lah. Okay. Okay. So at this point, I can say that this is, because the x is 1, the t is 1. So I use this one, u1, 1. Okay, so this one, because of x is 2, t is 1. So at this point, I will set this one as u2, 1. Boleh. So that means this point is u0, 0. And then this point is u1, 0. This point is u2, 0. Boleh? This one very simple, right? Boleh faham? Setakat ni boleh faham. And this is u1, 0, 1. Sampai sini okay? Until here okay or not? If okay, then you type okay. Yang ni dulu. Now okay or not? Okay, type okay. Tak okay, then type pangkah X. Okay. Now okay or not? Okay. Okay. So if let's say this one, and then continue until, so now I use I and I plus 1. Okay. Silap, sorry, saya sepatutnya sini saya guna J. Sorry this one I put J. This one. For the x-axis, I use I. For the y-axis, I use J. Okay, so here is xi plus 1. So that means here, at this value, here, this is ui, and this is 1, right? And this is ui plus 1, 1. Okay, boleh? Belakang tu, because this is T1. And that means, let's say, I draw until here. Sampai lah ke sini kan. Dia sambung lagi lah, Okay. So, at this point, so this is U apa? U apa? Any of you want to answer? Nuratika? Are you here? U apa? Agaknya sini, U apa?
UI
Yes.
J.
UI J. Okay, correct. So this one is UI plus 1 J. And this one is UI J plus 1. Okay. And this one is UI plus 1 J plus 1. Okay, boleh? So that means this is the coordinate. Bukan coordinate lah, the value of V with the name of it. Okay, satu lagi. This is the step size. Yang step size kat sini, let's say the step size here and step size here is same. So setiap kali pun dia akan ada step size yang sama, the same step size. So the step size here is actually this one lah, kiranya step size lah. Okay, so sini that's mean H lah. Normally we use H for the x-axis. So that's mean xi plus 1 minus xi. Kalau lah sini, here, this is step size. Let's say they have the same step size lah semua ni. Okay, they have same the step size. So this is normally we call for the step size for the y-axis lah, walaupun t lah, t kat sini. So this is the changes of t, where we normally use k. Okay, kita guna symbol k, and that means that this is a t j plus 1 minus t j. Okay, boleh. So far, okay? Okay, we continue. So now, okay, you know already, we have to draw a grid and then put in all the dia punya coordinate tu. Okay, now we go to the heat equations. So heat equations, just now I mentioned, right, we have two methods, explicit and implicit crank Newcastle. So we start with the explicit dulu. Explicit explicit method. Okay, we start with the kenapa tak keluar? Explicit method. Okay, so explicit methods, that means actually we want to solve the PDE, solve PDE at point xi t j. So boleh faham xi t j. Okay, x tu x pada dia punya kedudukan I itulah, and t adalah t kedudukan j. Yang tadi saya inform tadi. I draw just now. Wait lah, I find the note first. Mana nota saya? So the heat equation dia punya formula, sebenarnya dia punya equation punya formula macam ni. Kan tadi, that means we will have second partial of u respect to x dengan ada first partial, first del u terhadap del t gitu. So dia punya ni equation. Kalau tengok buku sebelum ni kan tadi this one. Okay, so sama ada normally minus 1 over c square del u del t equal to 0. Okay, this is the heat equation. Okay, so sekarang kalau tengok, if you look at page 217, you will see that we want to change this one. Okay, just now, you remember what is the independence variable here? X and t. So saya juga, I also can write it like this. Del u over del t for xi tj, because I want to solve the PDE at this point. So I write in here like this. Okay, so saya bawa ini ke sini, bawa macam ni, sama dengan bring left, bring right, and then we will get like this lah. C square, alamak, C, sorry, this is square. Second partial of u respect of x for xi tj. Okay, so here, kalau tengok this is first derivative. This is second derivative. Beza kan? Yang ni beza differentiate first beza sekali, yang ni beza dua kali. So if remember in chapter 5 numerical differentiations, okay, using the forward 2-point method kalau ini okay, basically this one we call it as we want to solve the PDE using we call it at forward time central space, or in the short form FTCS. Kenapa time? Because this over T. Okay, forwards. Remember, for the numerical differentiation that you have 2-point forward, 3-point forward, 3-point center, 5-point center. Remember. Okay, so this one we will use based on 2-point forward punya equation sebenarnya. Kalau lah sebelum ni, okay, 2-point forward sebelum ni kan, tulis bawah lah, saya tulis bawah. 2-point forward sebelum ni adalah macam ni kan, f prime x equal to fx plus h minus fx divide by h. Okay, so sekarang saya nak ubah this one right in the finite different form based on equation yang ni lah kiranya. So it will become like this. U I, sebab yang ni terhadap T, that means terhadap J. So that means this one is J plus 1. Sebab ini kan plus H, nampak? Lepas tu minus U I J divide by, since this one is over J. Remember just now, tadi, sorry. Masuk balik. I'm sorry. So just now remember this one. Yang ni for the y exit and exit here J. We use J. So this one is K, the step side. So here also we use K. Jadi kita tak guna H macam yang finite yang chapter 5 ni lah. So here we will use K. Okay, ke sini. Okay, sama dengan kan C square. Cuma yang ni, sebab this one is second derivative. Remember second derivative numerical differentiations ada berapa formula yang kita ada sebelum ni? Tipo, you remember or not? We have 2 methods.
No.
What is your answer? What is your answer, Tipo?
I forgot.
What you say just now?
I don't know.
You don't know? Habis lah kali ni student saya habis. Second derivative, you remember? Okay, now if you have book, you turn to page. Ada buku Do you have book, Tipo, with you? Do you have book with you?
Ada.
Okay. Wait I find chapter 5. Okay. Turn to page 122. The different formula 122. You see second derivative. How many formula that we have?
Tiga.
3 formula? You really got book or not? Yuzaimi. 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 Habiskan
Ya,
dulu.
doktor.
Awak tahu tak kita punya yang numerical sebelum ni differentiation tu kan chapter 5 untuk second derivative. Second derivative that mean this one. Okay, ada berapa formula untuk numerical differentiation yang awak dah belajar? Kalau ada buku page 1 to 2.
Itu yang sampai 5 point central tu doktor?
Ya, betul. We have how many? Ada apa point center? 5 point dengan apa?
3.
3 point kan?
Yes.
2 point, 3 point dengan 5 point.
Ada 2 point lah. 2 point tu untuk first derivative
Ni
saja.
tu first derivative ni 3 point dengan 5 point.
Ni second. Okay, second derivative we only have 3 point center and 5 point center. Kalau yang 2 point tu, kalau first derivative kita ada banyak. Kita ada 2 point forwards, 2 point backward, 3 point forward, 3 point backward, 3 point center, 5 point center. Kan? Okay. Now, saya tanya soalan ni je. Second derivative, we have how many equations yang kita dah belajar. Okay. Kalau yang kedua, if let's say we will use 3 point center punya formula. 3 point center punya formula kan macam ni. X minus H. Ni kan X minus H 2fx plus fx plus h bahagi dengan h square kan? Okay, sekarang yang ni, this one, I will adopt this formula. Cuma kat sini, it's respect to x. So apa yang akan berubah adalah I akan berubah I. So that's mean kat sini, kalau tengok saya, now I write in the finite difference form. This is a finite different forms. Kalau sini, x minus h minus step size. So tadi ingat, kalau lah u kan, saya punya step size kat sini, x minus 1. J dia memang J lagi. Saya tak ubah J sebab dia adalah respect to x sahaja. So minus 2u I j. Fx tu maksudnya point tu lah. Plus, okay, this one x plus h plus the step size. Yang ni lah, yang ni. Tadi kan saya dulu lukis, ingat tak? Yang ni, step size. Yang ni. So daripada sini dia tambah, daripada sini xi dia tambah step size, dia akan jadi ni x minus h. Maksudnya kalau ni xi dia tambah step size, dia akan x plus I plus 1. Kalau dia tolak dia punya step size, dia akan xi minus 1 kan. So tapi sebab sini x adalah paksi x, sekarang kita nak carinya u, value of u. Okay, kalau sebelum ni awak belajar, before this you learn in ODE, you want to find the value of y. Okay, now because in PDE, maybe the independence variable is y. So that's we want to find u. Kita guna another words lah. Maksudnya another, tak gunalah y, kita guna u kat sini. So kat sini jadi u, jadi apa? I apa ni sini? I plus 1. And then at j. J level sama aja. Boleh faham tak? You see this one This one is x minus h. X and then x plus h. Okay. For this one, find a different form. This is I minus 1. I plus 1. Boleh faham? Di mana we just stay the y. Dia punya j sama. Ni, yang ni stay je. Semua tu sama. Ni. J. Sebab kita tak ubah. Because this one is respect to T. Sorry. Respect to X. Okay. So kat sini, H. Kalau X. So this one is still lagi kita guna H square. Oh nampak This one, okay saya ulang. Just now, you have to remember this one. guys, you have to remember this one. This one. Macam mana? Apa yang kena remember sebenarnya? Sekejap. That means how we change to find a different form. You look at this one. This one just now, we want to find the partial of u respect to t. Kalau t, awak tengok ni t. Sebab t dia ni t. J saja. So kalau ikutnya, dia punya 2 point forward, apa nampak? 2 point forward, dia adalah x plus 1. X plus h minus fx. So maksudnya kalau ini j, sebab ini t kan. J plus 1, lepas tu minus j. Boleh faham tak? And because this one is t, tadi saya dah inform t that normally when we say the step sign, we use, kita guna symbol k. We use this k. So that's why here over k, bukan over h. Awak jangan tukar because if let's say this one is del t, that means you have to use k. Sebab kenapa you have to remember this one because x, kita akan ada paksi x, di mana paksi x adalah x, and the y exit here is t. And for the x, we'll using I, okay? I minus 1, I plus 1, okay? For the t, okay, that means the y exits, we will use j. That means j plus 1, turun ke bawah, j minus 1. Boleh tak? So that means here, if let's say I want to find this value, okay, turun ke bawah maksud ui. Oh, lama. Ke sini maksudnya ui j minus 1. Understand or not? If you understand, then you type 1. If you not understand, then you type 2. How to change to this, find a different form. This one is very critical because this is a basic. If you don't know how to change this one, then you cannot solve this PDE. Perlu saya ulang tak? Do I need to repeat it again? Class. Repeat Okay. Let's repeat again Okay. Sekarang, now we are in a heat equations. Okay. Heat equations, dia macam ni. Heat equations, it will have the second partial of u respect to x. Okay. And partial of u respect to t. Kalau kita tengok di sini, kita akan ada, we will have two independent variable, but one is x, another one is t. So that means, and we will have to find the value of u. So, maksudnya kita akan ada something like this lah, okay? Okay, so then, kalau lah ikutnya, the equation untuk heat equations adalah macam ni. Second partial of u, ni. Okay, now saya ubah dia dalam bentuk macam ni. Silap saya. This heat equation saya tulis balik. Sekejap. Okay. Kat mana? This one. Heat equation is del second partial of u respect to x. Okay. Alamak. Okay, ini dia punya formula umum. Del u del t equal to 0. Okay. Yang ni tak semestinya, it can be any value. Okay. So, tapi apa yang awak kena tengok adalah, okay, we have second derivative of u respect to x and and first derivative of u respect t. Yang ni yang perlu tengok. Yang lain, yang tengah ni value apa tak kisah. Sebab nanti we can substitute the value. Okay. Now, this one, we need to change it into finite different form. Okay, so that's mean this one I have to change to yang macam ni. Okay, awak tengok sebab this one is respect to x. Respect to x. Okay, so that's mean apa yang akan ubah adalah I. Okay, sama ada I plus 1 ke. Okay, so we will have to using kalau this is the second derivative. Okay, second derivative, you can refer, because in the final, it won't give you how to change from this second partial equation to find a different form. So let's say if you not remember, you can refer to the numerical differentiations for the second derivative untuk 3-point center. Yang saya cakap tadi kan, second derivative we have two equation. One is 3-point center, another one is 5-point center. So you use 3-point center to adopt. Tapi tak sama, this tak sama sebab that one is for a linear equation ODE yang biasa. Tapi this one because we have, this is PDE. So kalau ikutnya second derivative punya equations kan, kalau awak tengok buku in page 122. Okay. So in page 122, 3-point central different dia macam ni. Dia punya x plus, x minus h. Divide by h, alamak, h square. Okay, so now saya nak ubah from this one ke finite difference form. We call it, sekejap wait. Sekejap. Okay, we will change into finite different form. So that's mean this one, okay, kita akan ubah daripada sini. Okay, so yang ni respect to x kan. So here is u, I, tengok minus h, step size, minus 1. Kita akan guna. Okay, and then j, kita tak usik. Because just now, you remember I said that we want to solve at point xi, tj at this point. So maksudnya kalau xi kan, xi kita akan ada depan dia xi minus 1, belakang xi plus 1. So this one is mungkin this is a step size lah. And this is the step size, ada dia punya step size. Where for the x, the step size we will use the symbol h. Boleh. So here minus 2 u I j. Why is ij? Because we are solving at, well, I and j. Okay. Plus u I plus 1 j. So ini divide by h square. Ini boleh faham? Now okay or not? Can you understand? I'm blur, doctor. Kat mana blur? How to change the final different form? And now, okay, now I want to change. So this one is minus 1 over c square. Okay, so this one have to change to the final different form as well. And this one is respect to t. That means j yang akan berubah. So kalau kita tengok sini, this is the first derivative, bukan second lagi. Yang ni first derivative. So yang first derivative ini awak boleh refer kepada 2 point forward. Kalau 2 point forwards, dia adalah macam ni. X plus H minus Fx divided by H. So kat sini H, sorry. So here saya akan tukar kepada dalam finite different form like this. Daripada, saya tak jumpa mouse ni. Jauhnya. Mana ni? Tak ada tempat. So this one is U. Okay. So this one I, kita tak usik. We didn't change the I because this is respect to T. Respect to T, that means J saja. So that means this one is J plus 1 minus UI J. Fx dia adalah UI J lah kiranya. Kalau tengok di sini, ini UI J yang minus 2. Nampak? And then this one because of plus H. Step size tadi saya cakap sini. So apabila kita tambah satu step size, dia jadi XI plus 1. Boleh faham sini? So kalau sini, and then divide by H. Tadi saya cakap for the T, because this is at the y-axis, we use the symbol K. Sebab kita tak boleh, we cannot use both H because we have two independent variable. One is X, one is T. Yang ni tukar ke sini macam ni, okay. Dah okay belum yang ni? Still blur. Still blur lah. Ciyung, still blur. Tak sempat nak solve pun satu equation. Class, are you okay? Habislah, tak sempat lah cover syllabus macam mana. Alif, how are you? Alif. Okay tak? Ziqing today quiet.
Okay.
Totally out Pening dah.
Okay, dah okay.
Boleh?
Okay, still trying faham.
Sebab saya macam mana nak explain kalau awak tengok buku apa pun saya rasa tak boleh faham juga. Sekarang saya rasa looking great. Okay, sekejap. Saya remember this grid. Tadi kan, you can understand on this grid. Sekejap, saya back kepada just now, the grid just now. Okay, sekejap. Okay, this one understand or not this one? This grid. Okay, let's say we have X for the X axis. Okay, let's say this one, we want to find the value of U. Okay, now we want to find all the value of U here inside. All the point, this one, U11, all the point here. If let's say this one is X0, this one is X1, this one is X2, and X3, and so on lah. So I also can use Xi, or even I can use Xi minus 1. Macam ni. Kalau sini depan, yang ni Xi. So this one is Xi minus 1. Boleh. So, di mana where this one is, dia ada step size dia lah. Okay, the step size is H lah. Kat sini saya tulis ni, nampak ni, step size. So, dia daripada Xi, depan dia adalah Xi minus 1, belakang dia adalah Xi plus 1. Okay, kalau tengok sini, saya guna U. Okay, kalau at here this point, UI. Kebetulan this one is T is 1. Let's say we go out here. We go up here. Ni kan? Nampak this one? Okay. UI, J. Okay? UI, J. Kalau lah saya, okay, let's say I add the step size. I add 1H. Kalau sebelum ni kan awak kata, okay, kalau yang sebelum ni fx, kan fx tu kan. Kalau fx we plus h, I plus a step size. So when I plus a step size here, h here, then it become like this. ui plus 1j. Boleh? When let's say I minus fx minus h, that means I minus a step size here. So it will become ui minus 1j. Boleh faham tak? So that's come here, this one. This one. Nampak? Sorry. Kat sini. Boleh faham tak ni? This one. Fx as uij. Apabila plus fx plus h, that means dia ke right side. Dia akan jadi I plus 1. And when I say that this is x minus h, that means ui minus 1. Boleh refer to this one. Saya ulang balik sini. You see this one? Let's say the fx is this one. uij. Lukis balik. When we have here, yang ni adalah x kan? So we will have like here, this is I minus 1. This is I plus 1. Di mana dia, this one is the step size. Sama lah, let's say this one. So here, paksi y pula. This is t. Okay, so this is t. Where this one, at this point, this is j. And here it can say that j minus 1. Here is j plus 1. So katalah I want to get the value. This is a value here. So at e, this here is I, j, uij. Kan? I, j. Kalaulah I add the step size. Okay. Let's assume this one is similar to this one lah. Katalah saya tambah step size dia. So dia akan jadi this one. ui plus 1j. This one is respect to x saja ni. Y tak gerak, t tak gerak. Dia cuma x saja, x saja. X yang bergerak. Okay. So apabila this one is, let's say, kalau fx tu kan saya minus dengan satu step size. So dia akan jadi here. ui minus 1j. Boleh. So that's why just now when you look at the second partial of u, yang ni kan, second partial of u respect to x ni kan, we change to find a different form, kita akan jadi ui minus 1j minus 2 uij plus with ui plus 1j. And then this one over h square. Sebab yang ni we only respect to x only. Oh nampak? I minus 1, I plus 1 yang ubah. Yang I saja ubah. Ni, nampak? Yang j ni tak ubah. J is still j. Understood or not? Understand? Haris? Understand or not?
Yeah.
Sekarang boleh? Okay. Now, okay. Tadi, wait ah. Alamak. Sekejap. Okay. So, go back to just now. Another one is del u kan, del u respect to t, ingat? Satu lagi del u del t. So because we are Now is respect to T kan, del T. Maksudnya dia berkaitan dengan sebelah sini saja, J saja. Apa yang berubah adalah kalau kita guna 2 point forwards, dia punya formula first derivative adalah macam ni. X plus H minus Fx divide by H kan. So kalau tengok sini daripada di sini, this one U, I, J, yang ni kan. Okay, kalau saya, if let's say I add the step size ke atas, tambah lagi step size, dia ke atas sini lah kan. So dia akan jadi level J plus 1. So ini akan jadi U, I, J plus 1. Keluar lah. Boleh. And so that's why dia akan, yang ni when we change to find a different form, kita akan jadi U, I, J plus 1. And then minus U, I, J. Divide by H. Kat sini saya dah cakap, we use H over here, but over here, the step size of T, we using K. So here, you change to K. Sekarang boleh faham? No? Can you understand? If you understand, then you type 1. If you not understand, you type 2. So where are the others? So sekarang boleh. But you have to remember macam mana nak tukar ni. Sebab memang you have to change from the equations, PDE equation, to find a different form. This is the find a different form lah kiranya. Yang ni adalah find a different form. Yang ni benar lah ni. This one. This is the find a different form. Okay. And this is a find a different form. So, so the first thing what you have to see is whether this is the second derivative or first derivative. And then the second one is respect to what? Okay. Kalau respect to T, okay, that's mean Y lah kiranya. So you steps, dia punya ni H adalah you have to, maksudnya K. Kalau if respect to X, that's mean H. Okay, and respect to X, apa yang berubah adalah I. Okay, okay. Saya now I change to this word. Saya tengok apa dah wave equation dengan itu equation dia macam mana lah. Okay, so if let's say kalau lah saya ambil change another one wave equations, kan? Sekarang walaupun hit equation lah, saya nak awak faham macam mana change this second derivative, change to find a different form. Kalau lah untuk wave equation, dia akan ada second partial of U respect to X. Lepas tu dia akan second partial of U respect to T. Okay. So, sekarang awak boleh faham tak? Sekarang that means this one, if let's say I want to change to find a different form using the second derivative, 3-point center. Okay, saya akan jadi macam ni. U, sebab this one is respect to T. That means UI, I akan stay saja. Kita tak ubah. That means J minus 1. Minus 2 UI J plus with UI J plus 1. Boleh faham? And now this one is, sorry. And because this one is T. So saya tak boleh guna H square. Saya akan guna, I will use K square. Understand or not? So what is the difference between this one? Okay, again, yang ni adalah yang sekarang kita cari tadi. So here this is a UI minus 1J minus 2UIJ plus UI plus 1J. This one is divided by H square. Boleh faham tak? Yang ni, this one is because respect to T. So ini akan jadi K. And then this one is J minus 1, J plus 1. Tapi kalaulah apabila is respect to X, that means here is H. square, and this one is x minus 1, I minus 1, I plus 1. Yang J itu kita tak ubah. Okay, so now understand or not? Okay, boleh? Okay, boleh. Okay, so now understand. Okay, so I stop here first. And then we continue next class. Because I don't think that the example will finish within 15 minutes. Okay, so kita continue balik on. Hey, I want to ask class, do you have free on, wait if let's say we change the time to wait sorry give me some time I go and check first sebab macam ni, because I have to cover another lecturer, Dr. To. She is MC for 2 weeks, so that I have to teach her class. If possible, that I would like to combine, if possible, if can. Okay, on Wednesday, are you free start from 2 to 4 p.m. Wednesday? Because actually, initially our class, okay, sebelum ni kan our class is on Wednesday morning, 8 to 10 kan? No, not free, and you have another courses Okay, never mind. So we just continue on Wednesday morning. Okay, Wednesday morning we continue with this heat equation. We solve the heat equation. We do the example. Okay, so I stop our class here first. I hope that my battery reach, and then saya tak perlu tulis guna yang apa yang ni. Dia macam saya tak boleh nak agak sebab tak nampak. Okay. Oh, okay, it's okay. So it's okay. So I will I will do a separate class. Because Dr. To also scared that she got recorded class. If let's say you not understand, you can go and find the YouTube from Dr. Tay. If let's say she got record, I think that she got record on this one also, because I don't I didn't record this chapter because previously I share with Dr. To. I take the second half and first half, and she take the second half. So I don't have the video on this chapter. So we continue on Wednesday morning equation. So okay, siapa yang ada yang tak faham lagi? Ada yang tak faham lagi? Any of you? Ahmed in our class today, Ahmed? Habislah. Siapa yang tak ada dalam kelas ni pening nanti. Because for sure this chapter will come out with the final. Either heat equation, wave equation, or elliptic. Ataupun Laplace of Poisson lah. And hope that it will come out with the easiest lah. This one heat equation yang explicit adalah paling mudah. Compare to others lah. Ay, sempat ke? If I record, you understand or not? I'm not sure whether can understand or not. Okay, class, done. We dismiss. We continue next Wednesday. Say, stop sharing and stop. Okay, boleh. So far, ada masalah? Tak ada, and then we end our class today here. Sekejap. Tadi ada few students kan? 3 students.